All right, this is the second lesson in Excel. You're going to learn how to plot experimental and theoretical data on the same graph, which is what you're going to be doing in most of your lab reports. So this is right where we left off. Here's your experimental data. Supposedly, I went and I measured cylinders with diameters of 1, 2, 3, 4, 5, and I measured their circumferences, and I got 3, 7, 10, 13, and 17. And these are the measurements I took. This is not what an equation would tell me the circumference was. There is an equation that will tell me what circumference is if I know diameter. Its circumference equals pi times diameter. So how close are these numbers I measured to the values that that equation, c equals pi d, tells me they should be? So let me change this circumference to experimental circumference so I can keep track of it. And obviously in a lab report you would want to do that for clarity's sake too. Remember, I can make this wider if I want. And now I will call the value that the equation is going to give me the theoretical circumference. Now the equation is pretty simple. Circumference equals pi times diameter, so I can just put this in my calculator. I can do pi times 1 and pi times 2 and pi times 3, and I can type the numbers in here. And for 5 values, that's not a huge deal. That's not very difficult to do. It's not a hard equation to work with, but I want you to actually type an equation into Excel and get the computer to do these calculations for you. Have the program do it for you. So the first thing when you're entering an equation into Excel is you start with an equal sign. Once you hit that equal sign, that's telling this program you're going to have to do some math, which makes it happy. It likes to do math. So I'm going to use this equation, c equals pi d. Well, where is pi? It's not like a calculator. I don't see a pi button anywhere. So I'm going to start to type pi, and it's going to give it to me. Most recently used is pi. And there are a bunch of other things I can do here too. So here it comes up with pi, and this is the pi to the, I think it's to 15 decimal places. And if you're not sure how to use this and you use it wrong, the nice thing about Excel, let's say that I use this wrong, and in these parentheses I put a number. I know I want pi times diameter. Oops. And so I put a 1 in there because the diameter in this first case is 1. And then I hit enter, and it's telling me you did something wrong. And it tells me what to do if I want to figure out how to actually use this correctly. This will take you longer. The first time you do this, it'll take you way longer than punching this into a calculator. But once you get it, you've got it, and it can make things go much, much more quickly. So I'm going to hit OK. I already know how to do this. So when it wants you to use, when you want to multiply pi times something, for whatever reason, this program, just the value of pi, 3.14, is pi with an open and closed parentheses. You don't put anything in the parentheses. Why? Who knows, but you don't. So if I want to multiply pi times diameter, that is pi. What's on the screen right now, what you're seeing. As far as if I hit enter, that would give me pi. There it is, 3.14. So that is not what I want, though. I'm going to go back up here. I can type it up on that top line, or I can type it in the cell itself. I'm going to multiply pi times the diameter. When you want to multiply in Excel, you hit that little star key that is right above the number 8 on your keyboard. So that means multiply. So I'm telling it to multiply pi by something. Well, I know in this first case, the diameter is 1. I want to multiply it by 1, but I'm not going to put 1 in, and I'll show you why in a minute. I'm going to go click on this cell, and it says, all right, multiply pi by the number that's in cell A2. Now I'm going to hit enter, and I still get 3.14. Why did I click on A2 instead of 1? Because look what I can do now. Now I'm going to go back to the cell where I put this formula, and now I'm going to tell Excel the formula that you used in cell C2, I want you to use in all of these cells. I want you to apply the same formula in all of these cells. So I just went there. Let me hit undo and show you what I did. I clicked on this, and I dragged down this formula into all these other cells, and the computer did the calculation for me. And not only did it do the calculation for me, but it figured out what I wanted it to do. If we take a look at this cell here, C3, I can see that it multiplied. We can look at that top line of there, f of x equals, and it multiplied it by the value in A3. And if I go down here, it multiplied it by the value in A4. It figured out what I was doing. and that I wanted to go and multiply it by these diameters over here. It wasn't multiplying everything by the value in A2. So this is all done, and I put it in there, and that's fantastic. Now, if I had done this all in one step, then I could create a scatter plot. I can just highlight all 3 columns. But you remember that I've already made a scatter plot of the first 2 columns of diameter and experimental circumference. So now I'm saying just add another line for this theoretical. I want to add this data to it. I'm just going to go in this corner. Oops. I'm just going to go in this corner and drag it over. And look at that. It plotted all those points for me. Now they're red squares. I am going to have to add a legend to this. Remember the legend that I deleted before in that first video, but I'm going to have to add a legend. But first, let me add my trend line. I'm going to right-click on some of these new points for theoretical circumference. Add trend line. This is still linear. It put linear in for me. We can see if we go up here to the typograph, it did linear. And let's get an equation. Let's get an R-square value. And let me just make this a little bigger so you can see it. And here is this equation for my theoretical data. So what is this saying? This is saying that if we look at this equation, y equals 3.1416x. The y-axis variable is circumference. The x-axis variable is diameter. 3.1416 is pi. So this is saying circumference equals pi times diameter, which is true, which is actually the equation we use. The r-square value of 1 means that every single point, all of these red squares, which is what these points are for the theoretical data, every single point is on the line. So it's perfect correlation, which we would expect, right? I put in a formula and I said apply this formula. So I would expect this. Now I'm going to go into chart layout. I'm almost done, but I do want a legend because I want somebody who looks at this to know that my theoretical points are the red squares and that my experimental points are the blue diamonds. So you can put it wherever it makes you happy to put this. And look at this, it did it all for me. And it tells me that, it tells whoever's looking at this that this is a linear relationship. It tells whoever's looking at this that the little blue diamonds are the experimental and that the red boxes are the theoretical. So this is done.